Hi, I'm Aishwarya. I work as a remote DevOps engineer. So in this video, I'm going to explain you what is Docker in best possible way. There will be no jargons, no complex words. I'll not even consider that you know Linux, networking, Kubernetes or anything like that. I'll just explain a clear step-by-step explanation on what Docker is, why it exists and how it quickly solves the most complex problems in production environments. So let's get started. Imagine you're moving to a new apartment. Instead of carrying everything like your furniture, your kitchen utensils, and your clothes separately, you packed everything in labeled containers or boxes. Those boxes can be loaded into trucks, trains, ships, no matter what vehicle, but it never change itself. So Docker does the same for softwares. It packages an application with everything that it needs to run, including libraries, codes, setting for the codes into a container. That container will run same on your machine or your coworker's machine or whether that's a big server. Let's consider you build a Python application which contains specific data version along with 10 different libraries. Without Docker, you will tell your coworker to install Python specific version, after that install specific version for your database, and after that install these 10 different libraries using pip and set these 5 different environment variables. When running all these steps, there will be one thing that will misplace everything, but with Docker you will write one Docker file describing all the steps that you have told your coworker, and anyone, whether that's your coworker, a server or a CI/CD pipeline, can just run Docker container using Docker run commands and get exact identical application working on their machines, whatever working on your laptop. Everyone knows these concepts, but we will see how it actually works behind the scene. A container is not same as a virtual machine, and the difference matters. A virtual machine is a complete computer which has its own operating system, kernels on top of a hypervisor. But a container does not includes operating systems. It shares the host machine's kernel but isolates everything using few key features. Feature number 1, namespaces. Second is control group. Third is union file systems. How it isolates using namespaces. Let's see that. The namespaces gives a container its own isolated views of processes, networks, mount points, its IDs, and host names. The container thinks that is the individual residing on the machine, but actually it's not. How control group help isolating containers? It limits and accounts for resources like CPU, memory, and disk, so that container cannot hog the complete machine. Third, how union file systems help us isolate containers. It lets Docker build images in layers. Each instruction in Docker file contains a new layer which stacks on the previous ones. Layers can be cached and reused. What are the key components of the Docker? The first one is image. It's kind of read-only template for Docker containers. Second is container. It's a runtime instance for the images. Third is Docker file, which is kind of recipe to create in Docker images. Fourth is Docker registry. Use it to store our Docker images for sharing purposes. And fifth is Docker daemon. It's a background process which helps us create images, run the containers, and it talks with Linux kernel to set up those C groups and namespaces. So how it works? When you run Docker run my app, Docker daemon checks for the image on your local setup. If it's not present, it pulls it from the remote repository. It creates new set of namespaces. After that, it mounts the union file systems for the container, then allocate the C group limits and runs the application process inside a isolated environment, and whole this process get completes in milliseconds, not even minutes. But there are multiple misconceptions about Docker. Let's see that. First one is container is equals to virtual machines. No, they are not. As I have already explained, virtual machines have their own OS kernels on hypervisor, but for the containers, there is no separate kernel apart from the host machines. And that's the only reason container runs fast than the virtual machines. The second is Docker is equals to Kubernetes. This is also not true. Docker basically builds containers and Kubernetes help us orchestrate those containers on variable machines. Kubernetes help us manage, schedule, scale, and do networking part for the containers. The third misconception is containers stores persistent data by default. A container's writable layers can be destroyed. Once you destroy a container, the data is gone. To store data persistently, you need to explicitly attach volumes to the containers. The fourth one is one container is equals to one application. This is also not true. Best practice is actually running one single process in one single container instead of running whole application inside one single container. Why we use Docker? First, Docker help us for reproducibility of the applications. It increases the speed of deployments. Also, it is resource efficient. It helps us manage microservices, and there is a portability when we are using Docker containers for our applications. This is it for the video. I hope you have gained knowledge about what is Docker and why we actually use it in application development thing. If you like this video, hit that like button and share with someone who wants to know about Docker, and subscribe